We spent most of our time and focus here at DX Central on the art of DX, the actual hands-on part of DX where we have our hands on a receiver or an SDR, we have signals coming in from the atmosphere, and we write down what we hear. And that is DX. That's the fundamental part of it. But there's a whole other side that we haven't really touched on as well, and that is the technical aspect of DX. You know, the radio hobby in general is, by and large, pretty much DIY. It's homemade. You can buy a radio or receiver online, and maybe a couple of antennas that might be available commercially as well. But by and large, most of the gear that we use in the hobby is made in places just like this. A garage with a workbench, using wood and wire and PVC. And so it's with that idea in mind that we bring to you a brand new video series here from the DX Central YouTube channel. It's called DX 101 from the Workbench. Now, I'm embarrassed to say that even though I've been DXing for 30 odd years and I hold an extra class amateur radio license, a lot of the knowledge that I had gained over the years is now lost knowledge. It just never really kind of stuck because I never had a place to sit down and apply the concepts that I learned in hands-on approach. I never had a place to do any soldering or any work on building antennas and the such. That's changed. We now have a brand new workbench here in our garage here at DX Central, and it's the perfect opportunity for us to bring you into the garage here and bring you with us to the workbench so that we can talk about these concepts together and we can learn together. So if you're the kind of DXer that has an oscilloscope at home and you're kind of a weekend warrior electrical engineer, a lot of this is going to be review. But for people like myself who maybe had known this information at one time and forgot it, or maybe you just never knew it, you want to learn it, and it kind of scares you a little bit, this is going to be a perfect opportunity for you to get up to speed and see that there's a lot of this that looks scary and sounds scary, but it really isn't. So it's in that idea that we begin with our very first video in the series, Video 1, Terminating Resistors. So for today, we are discussing terminating resistors. What is a terminating resistor? Well, it's something that is commonly found in many electrical circuits, but for our purposes today, we're going to focus on the application and its use in AM receive antennas. And in that application, what a terminating resistor allows you to do is to introduce a hint of directionality into your antenna. And what I mean by that is basically it reduces the signals on one side of your antenna while allowing signals on the opposite side to come in a little more clearly, a little more readily. Now, there are many AM receive antennas that use terminating resistors in their design. Beverages is a great example. A beverage antenna uses a termination resistor on one end to give it that high sense of directionality. Loop antennas are also famous. Specific kinds of loop antennas like flag antennas, pennants, U's or EWEs, and for our purposes today, a Kaz antenna. A Kaz antenna, for those who are not familiar, is a version of a delta loop antenna. Now, normally when you think of a delta loop antenna, you think of something that looks a little bit like this. You think of something that is basically as high as it is wide. A Kaz is going to be a little bit differently, though, in its design. It's what we call a squashed delta antenna, which looks a little bit more like this. And it has a 1:4 aspect ratio. And so for every 4 feet in width, you have a foot in height. Now, my Kaz that I have here in my yard is 48 feet wide. And that means that the height of it is going to be about 12 feet in height. That keeps that 1:4 aspect ratio. Now, my antenna is oriented where one end of the antenna is pointed at 70 degrees. The other end of the antenna is pointed at roughly 250 degrees. So what I'm able to do by introducing this terminating resistor is I can actually swap between those two directions, but I can actually take that terminating resistor and I can use it to reduce the signals from one of those directions. Now, one side of the antenna will be where you have your terminating resistor. Let's just say for our purposes here right now, this is that end. I have 1,000 ohm resistor on one side of my antenna. We'll put on that 250 degree side. On the opposite side, I have my feed line, which comes in using a Wellbrook FLG100LN amplifier. This also acts as my impedance transformer to go from the wire antenna to a coaxial input feed line. The FLG100LN actually supplies 23 dB of gain into the antenna. So not only are we reducing the signals that we don't want to hear on one side of the antenna, we're putting a considerable amount of gain into the other side. This can be very helpful for pulling in weak or elusive DX signals using this antenna. Now, as I mentioned, you can swap these two. So I can move my termination box that I have here over to the other side and put my feed line on the opposite side. So now I would be reducing signals that are in that 70-degree area, kind of in this kind of pattern here, and boosting signals that are coming over here. Now, for terminating resistors, there are a couple of ways you can actually apply these into your antenna design. The most common use is by using a fixed value resistor, which is what I actually have in my existing setup that I have with my current Kaz antenna. And this gives you a fixed value. Now, the problem with that is that there is no one single value to give you the sharpest null on the back side. As you move up and down the AM radio band, you'll need different resistor values to give you the deepest null. You can also see variance based on the bearing or the orientation you have your antenna set, as well as the gauge of wire that you use. So for many DXers, the best way to circumvent this is to use a variable resistor. Now, there are different formats of variable resistors that you can use. One of the most common use is what's called a Vactral. A Vactral actually allows you, within the comfort and the convenience of inside your home, allows you to tune in that resistance to have the deepest possible null by using a variable amount of voltage sent through a coaxial feed line out to your termination box, which then gives you a variable amount of resistance. So from your shack, you can actually tune in that deepest null. The other form of variable resistor that you can use is actually a little more hands-on. Now, that's what I'm going to show you today, because this is actually something I'm working on for a design for a portable version of my Kaz antenna, where I will take my SDR out into the field or on a beach somewhere, something like that. I'll be at the antenna and I can actually tune in that amount of resistance that I need for the maximum amount of null. So today I'll show you how you can use one of these variable resistors in your design. I'll also show you how I am able to attach my fixed value resistors into my termination box without a single bit of solder in that entire system. So stay tuned. Alright, so I have all of my gear laid out here on my workbench, starting with my digital multimeter. This is actually a vintage unit I bought back in the late 90s, so this is a pretty old multimeter, but it's still kicking. We have a banana plug binding post set up here. This is actually the kind of binding post you would find in a speaker setup for like a home theater system or a hi-fi speaker. And the reason that I use this, I'll show you later, but it's so that I have a little bit easier way of connecting my terminating resistor here on these binding posts on the inside. We also have my variable resistor. This is what I'm going to be able to use to show you how to actually use this tuning knob here to dial in the appropriate amount of resistance that I need for the maximum null on the frequency that I'm trying to receive on. For today's purposes, we're just going to be using these Alligator clip cables so that we can do a quick connect, quick disconnect. No permanent connections needed here. We're just doing a test to show you and to make sure that my resistor and everything is working as it's expected to do. So let me actually show you a couple of other pieces we're not going to be demonstrating for today's video. We'll actually be using this in our later video when we show you how to construct a Kaz antenna. But to show you kind of the premise, this is actually a little project box that I bought on Amazon. It is a waterproof box. There's a gasket on the inside to seal out the water. And here's where I would actually drill some holes. And I would mount my two binding posts here on top of my termination box here that I would be using. My variable resistor right here as well. And then I would seal this off on the top with some clear silicone here. I've got some Gorilla silicone that I would use to basically watertight the seal here around these two components to make sure that no water gets inside my box. And that's it. That's going to be how that basically works. Now, again, the variable resistor is what we're going to talk about mostly for today, but we're also going to show you some applications using some fixed value resistors. Here's what I'm currently using in my Kaz as of today. This is a 1000 ohm fixed value resistor. So this is what I actually put in place on the back side here, these two posts here on the bottom of the binding posts to provide that resistance between the two wires that I need for my maximum amount of null. And what I'll show you here in a bit is how I actually connect that resistor using no solder whatsoever. So first, what I want to show you is how this variable resistor actually works. So I'm going to start by grabbing some alligator clip wires here. I'm going to use a red and a black, just to make it easier for me to be able to know what I'm working with here. I'm going to take my multimeter here. Okay. I'm going to take my two probes. I'm going to unscrew my binding posts. I'm just going to connect red to red and black to black. You can see here, hopefully, on these binding posts, there's a little hole right here. I'm just going to stick my probes in that hole and then tighten down my screw of the binding posts. That's going to hold those probes in. Now, when I do it this way, I have no resistor here on the back side of my post. Let me actually show you. On my multimeter, you'll see I have no resistance. Okay, if I put my finger in here, actually, I'm going to create some resistance here using my body. And you'll see that here. And so basically, that's what's going to happen. I'm going to put a resistor in between these two posts, and that's going to provide the resistance that I need to be able to provide a null in the signals from that back end of the Kaz antenna. So let me go ahead now and take one end of my alligator clips here and connect those. Red to red, black to black, making it nice easy, or whatever color scheme you're using. All right, so now we have to connect our variable resistor. Now, you'll notice there are two cables here, and there are three terminals on this resistor. So where do I connect it? Well, let me show you the different options. You could connect to the two outsides. So one on one side, one on the other. It really doesn't matter which one you choose. There's no polarity really on there. And you'll see what happens when I do that. My ohm meter here is actually showing me now I have about 1,112, 1112, 1113-ish. It's going to move around a little bit based on the cables that I'm using as they move and things like that. But a little over 1,100 ohms in resistance. Now you'll notice when I turn my variable resistance knob here, right? It's not making any difference. It's not changing the value of resistance on my meter. And the reason for that is by putting them on the two outside terminals like that, I'm actually now using the maximum resistance value in this potentiometer and using it as a fixed value. So whatever that maximum value of resistance is in that potentiometer, that's what I'm going to get. It's not going to allow me to use a variable function here to dial in that. So for our purposes, that's not what I want to use. So all I have to do is connect one of the outsides, doesn't matter which one, and one to the middle. And by doing so, you'll see now I have a low value in my resistance. Okay? Now watch what happens as I turn my potentiometer. You'll see my value begin to increase. So what I would be doing here in a live application of this use here is I would have my antenna set up. I'd have this mounted on my termination box. My SDR is sitting there. I'm out in the field somewhere, on a beach somewhere, with everything ready to go. It's sunset. I'm trying to pull some transatlantics in, let's say, and I want to get that maximum null on the west side of my antenna, that kind of southwest side, so I can pull in stations to my northeast and east in Africa and Europe. Okay, there's the real world scenario that I'm trying to kind of replicate here. So I tune to a frequency where I have a station to my west, southwest, that I'm trying to get rid of. I turn my knob until I get that maximum amount of null on my SDR or whatever device, whatever radio I'm using. Once I hear that station that I'm trying to get rid of at its weakest, that's my value that I'll stay at. And that's allowed me to dial in the deepest null. The other way that you can use this is if you are going to use this at your home, and let's say you don't want to spend the money or invest the time to build or whatever in a Vactral unit, and you don't want to have to keep running out and changing your values on your variable resistor here at your home unit, you can basically do a kind of a compromise. You can say, you know, for my case, let's say, in Charleston, South Carolina, where I live, most of the stations, the transmitters that use the AM band here in Charleston, are all to my west, southwest. So what I could basically do is I could connect my SDR, go out in the backyard, and I can dial in with this potentiometer here. I could dial in the deepest null that I possibly can get during the daytime of the biggest pest local channels that I have. And then once I find out what that value is here on my ohm meter, then I get myself a fixed value resistor of that value, and I put it in my setup, and there I'm good to go. So that's the other thing that you can do with the variable resistor here. You can either use it on the fly to be tuning in your value, or you can find what the optimal value is for your application, which then allows you to plug in a fixed value resistor into your termination box, and you know what now that value needs to be because you're able to find it using your variable resistor. What I'm going to show you now, though, is how I actually use a fixed value resistor in this same application without a single bit of solder. Alright, so I've taken off my Alligator clips and my variable resistor, and this is actually the method that I used when I used my 1000 ohm fixed value resistor in my current Kaz antenna. This is the exact process that I used to connect it. The reason for that is when I first built my termination box, I did a solder job. I soldered my resistor onto my binding posts and said, okay, that looks pretty secure. Then I went out and I went to put my wire on my binding post and I twisted to tighten it down, and I heard a thunk in the box, and my resistor had broken off the binding post here and fallen inside my box. I grabbed my ohm meter, realized I had no resistance anymore, and I was out of luck. So because my soldering skills are so poor, I decided I needed a mechanical connection to be able to do what I needed to do. And that's one of the reasons that I actually wanted to use one of these kinds of binding post setups, because I would have the screw here that I could use. And let me actually show you now how that works. So I've got my probe still connected here from my multimeter. Oops. Okay. And what we're going to do is we're going to unscrew the nuts. We're going to open up a little room here for me to put my resistor right across these two posts. So I have a spare 200 ohm resistor here that I have from another project, and you'll see I've got wire coming out. This is normally what you would solder into your circuit or whatever. So you see my multimeter here now, right? No resistance whatsoever. So let me turn that off so we can make this a nice big surprise. So I'm going to put my resistor kind of here in the middle. Doesn't have to be perfect. And then we twist the wire from the resistor on one post and on the other. Now we're going to tighten down that other nut, just like so. And at this point, that is a connection that's not going anywhere. That resistor is not going to fall off, no matter how much I have to tweak these two binding posts here to tighten down my wires. That will always be on there. So now, if I've done my job right, if I've made a solid electrical connection here, I should see roughly about 200 ohms on my ohm meter. 200.1. Not bad, right? So without using a single bit of solder, I was able to still do this. Now, this is an important concept because I am not a strong solderer, so I had stayed away from building one of these really fantastic antennas because I thought in order for me to make it, I would have to solder this resistor, and you don't have to do that. So this is one of those situations where you can actually not have to solder if you're not a strong solderer, if you don't have a soldering iron. You can actually still make this component for your antenna by using this kind of methodology. You don't have to be a strong solderer to do this. So the next question you're probably asking me is, but Loyd, I want to use a variable resistor in my setup. I don't want to use that fixed value. And how am I supposed to do that with these three terminals here? How am I supposed to connect a wire and keep it on those three terminals? And I actually have an answer for you. I have another variable resistor that I found online, another potentiometer that I found online. This is also a 1000 ohm variable resistor, and it has the three terminals just like the other, but you'll notice one little difference here. You'll see that this potentiometer on the terminals has little holes in it. And what I could actually do is I could get a small, clip of wire, put it inside that hole, strip the coating off the wire or whatever, put it inside that hole, and really kind of twist it on there. I could even use a little bit of silicone to seal it or whatever I need to do to kind of make sure it doesn't go anywhere. And then put the other side of that on my binding posts, and I'm good to go. And I just put them on those two little terminals right there, or the two over here, whatever, and I can connect that there. And I don't have to use a single bit of solder. I just basically have it go through that hole that's on here. So I'm going to put links to all the different components you see here, the binding posts, the two kinds of variable resistors, the alligator clips, all of that. I'll put these links in the description on the video. That way you can go out and find your own versions and play around with it. Don't be scared. I was scared for years. That's the message I want to make sure that I tell you here today. For years, I was scared to build these components because I thought I had to have a sophisticated setup to be able to do the soldering and everything else and an advanced technical know-how to be able to make these connections. And you really don't. This is super, super easy stuff. I can do it. I know you can do it. It basically just takes a little bit of time to sit here and put this together. You need a drill or some way to put your binding post on here and drill a hole for your variable resistor if you want to use that, or if you're going to use your fixed value resistor, then you just have to put that in place like we talked about, and that's it. And then your wire and a 12-foot painter's pole, and that's it. And then your FLG100LN, which is not cheap. I'm going to be honest, it's about $260 US. It's very, very much worth it. Now, if you don't want to go that route, you can also wind your own impedance transformer around a ferrite core. That's going to be for another video for another day. So if you have that knowledge, you'd like to do that, by all means, go ahead. I'll include some links on my description as well that'll show you what you would need to do to build that. But really, for the termination resistor by itself, everything you need is right here. I got my binding post, a resistor of whatever value you need to use. 1,000 ohms is usually pretty close. It'll get you pretty close to it. Or if you want to use the variable resistor, there you go. And that's it. So you can do this. Get yourself out there. Start building, start planning, and get some great DX on one of these fantastic antennas. I am a huge proponent of the Kaz, and as a follow-up to this video, we'll be doing a video of my next Kaz build, which I'm planning on possibly doing this weekend, to put a new Kaz antenna in the air. So whenever that is, we put that up, I'll be sure to do a video to show you how I construct it and some of the methods that I use to do things like measure out the wires and so forth. So stay tuned for that. As always, if you found this video to be helpful, don't forget to give us a thumbs up and click on subscribe and the bell icon so you can be notified when new videos are available. As always, my friends, from all of us here at DX Central 73, and best of DX.